Hello students, welcome back to the virtual class. Today we are taking up with the new concept, that is ratios and proportion. So let us start the session. Try to understand the concept. So this will help you to deal with the practical part on both the concepts. Okay. So let us start the session. So here ratio means if A and B are two quantities of same kind, then the fraction is called ratios of A and B. So that means here to see, for to say that as a ratio, it should be of a same kind. That means whatever you are comparing, it should be the same one. If you are comparing with the kg, you have to take another one also with kgs only. Or if you are comparing with the price, it has to be price for same. With the different items you are comparing with the price, kgs or a time, whatever it may be, it should be of a same kind. That is termed as ratios. See, in the continuation part they are saying ratios as one of the quantity to another in relation in aspects of number of times that one quantity contain the other. Okay, it is always expressed by the fraction obtained by dividing the first quantity by the second one. So here ratios is always expressed in the fraction, and a ratio between A and B is generally represented as like the ratio of A and B, or the ratio A is to B, or it may be A by B. So it can be, ratio can be represented either in ratio of A and B, or A is to B, or A by B. Okay, so the quantities A and B are called the term ratio. Okay, the first term, that is A, is called antecedent, and the second term, that is B, is called consequent. Okay, so here I have given the definition of ratio. Ratio can be defined as a relationship between any two or more number expressed in the same unit. So same unit is very important. Okay, that is what I have explained here. So which is found out in some arithmetic form with a view to meaningful comparison between any two or more related phenomena. So here, for comparison, to have a meaningful comparison, we should have a same kind. That is what I told you. If you are comparing A with B with respect to price, or with respect to the quality, or with respect to the kgs, whatever it may be, if you are comparing any two items, the base, the kind should be of the same. That is very important when it comes to ratios. Okay, this you will understand. This is needed for practical part of the concept. Okay, we'll take up the next part. That is here we have a different forms of ratios. Okay, altogether we have a 10 different forms. The first one is unit ratio. See, unit ratio is one where both the terms are equal. That is like I have given the example, 1:1, 3:3. That is unit ratio. Here antecedent is always equal to consequent. Such ratios are called unit ratio. Then we have inverse or reciprocal ratio. So here a ratio is said to be inverse or other if their product is 1, and okay, that means in other word, inverse ratio is one which is obtained by interchanging antecedent and consequent. See, I have given the example. So here we are interchanging the antecedent and consequent. So if A is to B can be interchanged as B is to A. So this is termed as a inverse ratio. That means if A is 1 and B is 3, so if we are interchanging it as 3:1, that is termed as a inverse or a reciprocal ratio. Then we have a compound ratio. See, compound ratio means so if you are considering A, B and C, D are two ratios, then ratio of, see, we are compounding the given ratio. Okay, so that means if they are given two set of ratios like A is to B and C is to the D, we are comparing it as AC is to BD. Okay, like see, I'll just quote this: AB double is to C is to D. We are considering the extremes and mean. Okay, we are we are considering the first and third, second and the fourth. Okay, that means we are compounding the first, third and second, fourth, that is compound ratio. Then we have a duplicate ratio. Duplicate ratio is when a compound when a ratio is compounded by itself, the resultant ratio is called duplicate ratio. That means a's to b or ratios and z to b duplicate ratio. Okay, so that means see here it is a square and b square. So a square and b square is said to be duplicate ratio. I am take an example also. See the duplicate ratio, if 2 is to 3 is a ratio, the duplicate of this is 2 square is to 3 square, so we are getting 4 is to 9. So that is duplicate ratio. Okay, all this is needed for you. Okay, so they may ask give an example for compound ratio, or solve this use under compound ratio, like that, or they can ask you define what is compound ratio or what is reciprocal ratio, like that. So that is why it is very important for you uh, to know what is all, and this will be helpful to you to solve the practical part, as I told you earlier. Okay, then we have a subduplicate ratio. So subduplicate ratio is one which is obtained by making a square root of the respective terms of a given ratio. Say for example, if a is to b is a given ratio, if you are using a square root for me, that means it is a subduplicate ratio. Okay, so in duplicate we are coding the squares, so here we are using the square roots. Okay, that is subduplicate ratio. Okay, I have given the example 9 is to 16, so root of 9 and root of 16 we are getting 3 is to 4. So this is subduplicate ratio. Okay, well, we'll move on to the next type, that is we have triplicate ratio. See, duplicate and triplicate resembles the same, only thing is triplicate 3. So here we are using it as a 3. Okay, that means, so a triplicate ratio is one which is obtained by taking cubes of a respective terms of a ratio. So the here we are using a cubes. Okay, so I have quoted the example of example also. 2 is to 3, 2 cube, 3 cube, you are getting 8 is to 27. This is triplicate ratio. Okay, like that we have a subtriplicate. Similar to that, subduplicate we are using a square root, here we are using a cube root, that's it. Okay, that is subtriplicate ratio. Then we have a continued ratio. See, continued ratio is a ratio where when the relationship between three or more aspects of a same kind is expressed in the form of a ratio, then it is called a continued ratio. Usually we are comparing two ratios. Okay, so if we are comparing more than two, okay, that is continued ratio. That is what I have quoted here. See, for example, 3 is to 4 is to 6 is to 8. Okay, this is also can be written as like 3 by 4 or 4 by 6, 6 by 8, like this. So there is a continuity here, so that is continued ratio. Then we have a ratio of greater inequality. See, ratio of greater inequality, if a is to b is a ratio where a is greater than b, that is antecedent is always greater than the consequent, such ratio is termed as a ratio of greater inequality. When it's come to ratio of lesser inequality, where antecedent is less than consequent, where a is less than b, such ratios are termed as a ratio of lesser inequality. Okay, so this is all with respect to ratios. So the next part of the concept is proportion. So proportion is also very important concept. Okay, here also we are dealing with a practical part. Okay, with respect to this concept. Okay, try to understand what is proportion is. Okay, proportion represent two equal ratio when four quantities a, b, c, d are related as a is to b is equal to c is to d. Then a, b, c, d are said to be in proportion. Okay, so whereas it's called, see, where here we are comparing four different quantities. Okay, a, b, c, a, b, c as well as d. Okay, a is called the first proportion, b is the second a term or a second proportion, C is a third term, and D is a fourth term. Okay. So if A is to B is equal to C is to D, A and D are called extremes and B and C are called mean. Okay. See, AB is equal to C is to D. This 2 is called mean. Okay, A and D is called extremes. Okay. So that is see, we are trying to represent two equal ratios when four quantities are given with respect to the proportion. Okay, so here A is to B is equal to C is to D, BC is called mean, and AD is called extremes. And here we can also write this as AD is equal to BC, or A by B is equal to C by D. See, we can cross multiply also, you are getting the same only. So that means we are taking extremes as well as the means aside. Okay. We have rules with respect to proportions. Okay. So rule of proportion. Um, so here in a given proportion, since two ratios are equal, we have a product of, see, always product of extreme is equal to product of mean. That is what I told you. A D is always equal to CD with respect to any of the thing. See, we are comparing extremes and the means. Okay, either you can write it as A by B is equal to C by D. So if you're cross multiplying, you're getting this equation only. That is what they have given. Product of extremes is equal to product of mean. Okay, so here also we have a different forms of proportions. Okay, so let us move on to the next concept, that is different forms of proportions. Okay, see here under different forms, the very important forms is direct proportion and indirect proportion. Based on this two concepts, we are working out the sums, and this is very very important from the examination point of view, people. Okay, so let us understand what is direct and indirect proportion is. Okay, see, direct proportion, the term are said to be in direct proportion when an increase in a value of one term is followed by the increase in value of another also, and if there is any decrease in the value of one term, is always leading to decrease in the value of another term also. So whatever you are comparing, so if there is any increase, which is leading to increase of the another term also. If there is any decrease in which is leading to decrease of another proportion also, that is said to be direct proportion, where the proportions are directly relating to each other. Okay, so we can take an example of working days and wages paid on daily basis. See, if you are working on a daily basis, if there is any increase in the number of days you are working, the wage you are receiving is also increases, right? So that is increase in one object which is leading to increase of another also, where these two are directly proportional. Increase of one with leading to increase of another also. That is the example for direct wages. Okay, the next one is indirect or inverse proportion, just opposite of a direct proportion. So here an inverse proportion consists of a negative role between terms. Okay, so that means when there is any increase in one value, which is leading to decrease of the another one. Okay, if there is any decrease of one value, which is leading to increase of another value, that is indirect or inverse proportion. The best example we can take for this is speed and time taken. Okay, so if there is any speed, or if the speed of a vehicle is increasing, which is leading to a decrease in time consumption to reach the destination, right? So that is indirect or inverse proportion. Okay, so we are working out the sums based on these two concepts also. Okay, well, we'll move on to the next forms of proportion. See, we have simple proportion. Simple proportion is one where we are containing only 4 terms. Okay, no any other extra terms here. We are comparing a b c d only. So simple proportion, the missing value of any term can be obtained with applying the rule of 3. So rule of 3 means here we know the values of 3 things except one term. So with the help of that, we can able to solve the we can able to find the value of the another missing value. Okay, so I'll just take an example for the simple proportion. Say for example, a is to b is equal to c is to d. So if a is 2, b is 4, we don't know the value of x c, assume it as x, and value of d is 2. So here what we usually do is we are comparing the extremes and the mean, right? So multiply this 2, you are getting 4x is equal to 2 2s are 4. So x is equal to 4 by 4, you are getting a value of x as 1. So that is how we can able to calculate the value of the unknown term with the rule of 3. So rule of 3 is where the fourth or a missing value can be assumed as x, that is rule of 3. Okay, this thing you can expect 2 marks question on this concept. Okay, then we have a compound proportion. When the number of related terms in a proportion exceeds 4, it is called compound proportion. That means we are see here the proportion is more than 4. Usually in the simple proportion we are comparing only 4 terms a b c d. So in the compound proportion we can comparing more than 4. We are comparing e f g h also. Okay, so continued proportion is 1. The next one is continued proportion. Here it is 1 which contains a chain of ratio. So chain of ratio is like see, a is to b is equal to b is to c, that is equal to c is to d, like that. Okay, this is equals d is equal d is to e, like there is a continuity in this kind of proportion, that is termed as a continued proportion. Then the last one we have a mean proportion. See, mean proportional is if a or b are continued proportion, then b is called mean proportion between a and c. Okay, so here we are only having a b c. Okay, and if a and c are a proportion, then b is called the mean one. Okay, usually if we are having a 4 terms, bc will be the mean. If we are having only 3 means b is the mean proportion. So that is what we have given. See, I'll just quote the example for this also. See, based on simple and mean proportion, you can expect questions. Okay, so here a b is mean. Okay, if they are given a b c, we can write it as a by b is equal to b by c. Cross multiply this, you will get b square is equal to ac, b is equal to root of ac. That is what I have quoted here. Okay,